Okay, so let's go ahead and try this example here. So we want to get the x by itself, so we'll start with adding 4 to both sides. And then to get the x by itself, we're going to divide both sides by the coefficient. So we're going to divide both sides by 2. We don't switch the sign because this number here that we put on both sides is not negative. This is negative, but what we divided by is not. So no need to switch the sign. To get the x by itself here, we're going to add 5 to both sides. And then lastly, divide by 7. Okay, so I'm going to start with my rough draft. So I'm going to start with -2 because it's smaller. And it says, shade all the numbers that are greater than -2. So all the numbers that are greater than -2 would be on this side of the graph. Here it says, shade all the numbers that are less. Makes an L for less. Less than 1. So that would be all the numbers on the left here. Okay, so now we go back and we look at the problem and it says the word or. So or means include everything. Wherever they're shading, include it. So if we look here, they're shading. If we look here, even though the parenthesis means don't shade, this other shading goes right through it. So it means there is shading there. They're shading here, they're shading here, they're shading everywhere. So that is why our answer is just going to be a completely shaded graph. You could put whatever numbers you want on this graph, but every single number is a solution. So if you want to put like 0, 1, 2, 3, 4, you can. Every number works. Any number at all. So you should have a totally shaded graph. There should be no parentheses, and there should be this parenthesis there shouldn't be there because, again, this shading goes through it, which means include it. So this -2 is included because of the blue shading here. So my interval notation, if we go from the left to the right, would be -infinity, comma, and then it's going infinitely on the positive side as well. So that would be our solution. Now, just to practice, if instead this was an and problem, then you would only be including this part because that's where they both are shaded. So our answer from the left to the right, oops, did I forget the one here? Left to the right would look like that. So that's the difference. All real numbers versus and. Okay, so now to make sure that we really understand what or means. So if we take our original problem, the word or means the number we plug in has to work for one of them, this one or this one. Whereas the word and means the numbers for x have to work in both. So since we have here all real numbers, it means any of these numbers will at least make one of these work. So for example, if I were to pick, let's say 4, I'm going to pick 4. And if I put 4 here and 4 here, it has to work for one of them. It could work for both, that's great, but it has to at least work for one. So over here we have 8 minus 4, that's 4, and 4 is greater than -8, so it works, so we're good. Now I'll just check this one anyway. And it doesn't work. 23 is not less than 2. But the word or just means it has to work for one of them. If it has the word and, it has to work for both. That's the difference between or and. Okay, so now let's take a quick second to practice a little bit more. This is not in your note packet. So what I'd like you to do, either get a separate sheet of paper or on the side of your note packet, pause the video, and tell me what you would put for your answer if in between these it had the word and. And then tell me what the answer would be if in between them I put an or. So let's say you graphed it all. This is your rough draft. This is not a final draft. Tell me what your interval notation answer would be. So again, pause the graph, write your answers down, and then push play. Okay, so there's the first one. Here's the second one. Make sure you're pushing pause or I'll be going too fast if you don't. Here's example 3. And then here's example 4. So again, pause it. Okay, so pause your video because I'm about to give the answers. All right, so let's see how you did. So for and, it means where are the solutions that work for both of these? So if we look at the graph, it would be this area right here has both the shading. So if we go left, it's going infinitely to the left, and then it stops at -2. So that would be your answer if it was and. Now, or means include all of them because all of these will work for one or the other. So not these, but include all of this. So -infinity, and then all the way to -4. Okay, let's check number 2. So if it was and, we're looking for where are the solutions. So for this to be and, we're looking for where both the solutions are. So it'd be just right here. So for and, it would be 0, comma, or parentheses 0, comma 9. So any number in between 0 and 9 would work for x here and here. Now for or, we want to include wherever there's shading. So there's shading through the whole graph. So -infinity all the way to infinity. So that means any number can go in for x here and it works for both. So for example, this number right here. I'm sorry, I said that wrong. That means that any number that you pick, so for example 10, will work in one of them. Whereas these numbers here, so for example 5, would work for both of them. So if I pick 5, 5 is greater than 0. 5 is less than 9. So that's what the word and means. These numbers work for both of them. Whereas all real numbers means any number you pick, so for example 10, will work for at least one of them. So 10 is greater than 0. But 10 is not less than 9. It doesn't work here. So or means it only has to work for at least one of them. Okay, so and. So we want to see where the solutions both go. And there would be none. So this one would be no solution. Or we can call that the empty set. Or a 0 with a slash through it. Or means include everywhere there's shading. So here there's shading, so -infinity, parenthesis around that, all the way up to -5. And then we have this spot where there's no shading, so that's when we use this symbol here. And then any number, including -3, that's what the bracket means, and greater, so infinity. So this would be this is the difference between and or. No solution versus these solutions. Okay, so now if we look at the next example here, if it had said and, we would only include these solutions. So from 8 to infinity. Whereas if it was or, we include all of them. So from 1, including 1, and then it goes infinitely on. Okay, so now the next 4 examples are going to be in the next video. Make sure to try numbers 5, 6, 7, and 8, and then once you've done that, You can watch the next video and see if you understand this on your own. So go ahead and try these next problems.